All right, let's talk about STEM. You've seen that acronym everywhere, right? It's one of the biggest buzzwords in education today, slapped on everything from kids' toys to national policy. But what does it really mean when we talk about teaching it? Well, we're going to dive in and demystify the whole thing.
Because that's really the heart of it, isn't it? Beyond just, science, technology, engineering, and math, what's the big deal? What does this change actually feel like for a student in a classroom? We're going to break down what integrated STEM is all about, using some great findings from the national academies.
Okay, so before we can even get into the how, we really need to understand the why. Why is there this massive push for STEM? I promise you, it's not just some passing trend. It's a direct response to some really specific, really important needs. When you get right down to it, leaders in both government and business see STEM skills as absolutely critical for a few big reasons. First, it's about keeping the country innovative. Second, it's about making sure the next generation is ready for the jobs of the future. And third, and this one's huge, it's about making sure all of us can navigate a world that is just soaked in technology and science. It's not just for future rocket scientists, it's truly for everyone.
This brings us to the core idea of this whole explainer. Integrated STEM. And that word right there, integrated, that's the key. It represents a huge shift from how most of us probably remember school.
And this slide just nails the difference. Think about it. On the left, that's the classic school day. The bell rings, you slam your math book shut, you shuffle off to science, everything's in its own little box, its own silo. But the integrated approach on the right, it just smashes those walls down. It says, hey, let's take a real-world problem and throw math, science, and technology at it all at once to figure it out. Because, well, that's how the real world actually works.
And listen, this isn't just some theory that educators cooked up. It's a reflection of how science really gets done these days. This quote points out that even in a field like biology, the biggest discoveries are happening when you bring different fields together. You've got physicists and computer scientists and engineers all working together. So the whole point of integrated STEM is to get students ready for that collaborative world they're actually going to be a part of.
So, if that's the big idea, how do you actually make it happen in a classroom? How do you get kids to start connecting those dots? Well, the answer is to shift the focus away from just memorizing facts and towards solving problems.
One of the main ways they do this is with something called problem-based learning, or PBL. So instead of cracking open a textbook to Chapter 1, a lesson might start with a messy, real-world challenge. Students have to figure out what they even need to know to tackle the problem. It completely flips the script. The problem itself drives the learning. And a lot of these projects are built around the engineering design process. Now, this isn't just for people building bridges or skyscrapers. It's really a way of thinking. You figure out your goal, you understand your limits, like your budget or your timeline, you brainstorm a bunch of solutions, and then you test them out. And you fail, and you learn, and you improve. It's a cycle that teaches you how to think critically and not give up.
Let's make this super concrete. Instead of doing a boring worksheet on how to calculate area, what if the assignment was to design an energy-efficient bedroom? All of a sudden, geometry isn't just a bunch of abstract formulas. It's how you design the floor plan. Percentages aren't just random math problems. They're how you manage your budget. And those science concepts about heat and insulation, now they're crucial. It all comes together to solve one real, tangible problem.
Now, this all sounds pretty amazing in theory, but it leads to the million-dollar question, and it's one that researchers at the national academies were really keen on answering. Does this stuff actually work? Let's take a look at the data.
Because at the end of the day, good intentions aren't enough. We have to see what the research says about how students are actually doing.
Okay, so let's unpack this a bit. When it comes to learning science, the evidence is pretty positive. Students seem to really get scientific concepts when they're taught this way. Now, for mathematics, the results are a little more mixed, a bit less consistent. It seems like the math really has to be explicitly and clearly tied to the project for it to stick. And finally, what about just getting students interested? Well, here, the approach shows a ton of potential, especially for getting kids from underrepresented groups to actually see themselves as scientists and engineers.
So what's the big takeaway from all the research? It's basically cautious optimism. Integrated STEM is a really powerful tool, for sure, but it is not a magic wand. The research makes it clear it's supposed to be a bridge connecting strong subjects, not a replacement for them.
And that brings us to our last and I think most important section. If this approach has all this promise, but also some real challenges, what's the one thing that makes the difference between it working and it, well, not working? And the research from the national academies was just crystal clear on this point. After they looked at all the different programs and all the data, the success of this whole endeavor really comes down to one single critical factor.
The teacher. That's it. The person at the front of the classroom is, as the report puts it, the key factor. The success of this entire model rests on their shoulders, on their knowledge, their confidence, and their training.
And if you want to see just how big of a challenge this is, just look at this number, 4%. According to a national survey, that's the percentage of elementary school teachers in the U.S. who feel very well prepared to teach engineering. Just 4%. That one number really shows you the scale of what we're talking about here.
So if teachers are the key, what do they need? You can't just hand someone a new curriculum and expect miracles. They need deeper knowledge, not just in one subject, but across several. They need new skills for teaching this way. They need time to plan with other teachers, and they need really good, high-quality training. It is a huge professional lift. And I want to end on this quote because it busts the single biggest myth about integrated STEM. The goal is not to water down the subjects to make them fit together. It's the complete opposite. The point is to build real expertise in math, real expertise in science, and then show students how to build bridges between them. You just can't connect dots that aren't there in the first place.
So we'll just leave you with this final thought, which really gets to the heart of this whole movement. What if the main goal of school wasn't just to accumulate facts, but to learn how to actually use those facts to go out and solve the real complex problems that shape our world? It's definitely something to think about.